this is problem 8-75. Is the quantity x minus 5 squared equivalent to the quantity 5 minus x squared? Explain why or why not. So there's a couple of different ways we can prove this. First one that probably most people would think of is actually to multiply this out and see if they're the same thing. So that's how I'm going to start, but I'm going to show you a couple other ways too. So x minus 5 squared is the same thing as x minus 5 times x minus 5. Okay? So we're going to multiply those together, so you can either think of it as the distributing or FOIL or the generic rectangle, but this one we should be pretty good at. So we get an x squared, this inside is minus 5x, this outside is minus 5x, so minus 10x, and then negative 5 times negative 5 is plus 25. So that's what that first one is. Let's see if the second part equals the same thing. So 5 minus x squared. That's the same as 5 minus x times 5 minus x. Okay? Same way, we're going to multiply these. 5 times 5, we get a 25. Negative x times 5 is negative 5. 5 and negative x is negative 5x again, so we get negative 10x. Negative x times negative x is positive x squared. So actually these two things we see right here are exactly the same. They're in a different order, but that's fine. The signs are in the same with the same variables. So that's good. So yes, they are equivalent because we multiplied them out. Multiplied and they equal the same expression. You could say that. Okay. Now I'm going to show you other ways and using your calculator to decide if these are equivalent or not. So we're going to graph them both, and they should be the same graph if they're equivalent. And then also we can look at the table and see if they're equivalent there. So I'm going to just type this in, x minus 5 squared, and then the other one is 5 minus x squared. Graph it, and they should be the same thing. So we should really only see one graph. If you have a color calculator, that's even better. Or if you're using the Inspire, you can see, so there's one graph here that are the same, so that also is a way that we know that they're equivalent. And then one last thing I'll show you is the table, or if you were to plug in numbers, if you can see that they're plugging in negative 2 gives you a 49 for the first, and then 49 also, and you see they're identical all the way down. So you know that all those values, they're giving you the same values and same outputs when you plug in the input into both of those expressions. So they're definitely equivalent.